scratch. I hope this would be interesting for you folks. And this talk is mainly for security engineers. About myself, not a lot of things to say. I'm a cloud security researcher and a trainer. I secure cloud and cloud native infrastructure, as simple as that. The agenda of this talk is two things. One is cut the crap. There's a lot of news on the internet, on YouTube saying that okay, AI is going to take away your jobs. It's going to make, it's like, it's all negative, right? It's going to take away your jobs. It makes harder for juniors to enter the job market and all these things. And I want to show the demos and like show you what exactly LLMs are and what exactly people mean when they say AI, right? And also the second part of this is if you use LLMs, if it's the solution for your use case. Let's get started with the basic question. Like what is AI? What is artificial intelligence that so-called all the experts are speaking about? I'd take two approaches here. One is the top-down approach and the second is bottom-up approach. The top-down approach is, okay, on a very high-level view, right? What does a term mean? Like what does cloud security mean? It is securing the cloud, right? As simple as that. What does artificial intelligence mean? It is simulating human intelligence by machines. Like this is so 10,000 level feet view of what artificial intelligence is. The other way is we take all the things that are present in the market and then we try to say, okay, then we try to distill what exactly is artificial intelligence. Then we get a glimpse of what exactly that is in the market, right? Now the top-down approach works. Everyone says that okay, it is simulating human intelligence by machines, but the bottom-up approach is it's tricky because people use a lot of things and call their products as AI-driven or AI-powered or AI used. Like for example, automotive cars and say robotics, even your face biometrics and stuff, right? All of this use some or the other form of AI. But that doesn't mean it's the only product that is AI, right? So it's very tricky to say what exactly is AI by looking at all the solutions out there in the market. If you look at the academic side of things, AI is a huge domain. Like AI has so many things. There was, like if you look 3 years ago when AI was not the boom, there was something called NLP, which nobody talks even now, right? But in AI domain, LLM is a very, very small space. Like LLMs are part of generative AI, which is part of deep learning, which is again part of machine learning, which is AI. So when folks make this hype of saying that, okay, we are AI powered, right? Maybe all they're doing is just LLM and calling their thing AI. It's like you secure just your S3 buckets and call your cloud as secure. Like it doesn't make sense. It's just for the hype folks. So LLMs are part of generative AI. Generative AI are AI systems or probably systems that generate some kind of content. LLMs are just the text part of it. But Gen AI, generative AI also includes models which goes ahead and generates other form of content. For example, let's say images, videos and all. LLM is just the text part. The others are also part of generative AI, but they are not large language models. So pro tip number one, if you are a student, working professional, whoever you are, ask folks what do they mean by AI powered. And like I'm pretty sure, be it whoever it is, your professor, some vendor selling you product or some consultancy, after one level, after you ask this question, you can see the response and find out what the solution they are selling, if they know the solution they are selling or not. Okay, now let's go into the small part that we are talking about, large language models. I'm not talking about anything else. I'm not talking about ML or DL and stuff, just the large language model part. These are pattern prediction systems. They have no clue or they have very less clue on what exactly the text is, but all they know is, okay, if I give a sequence of words, they know how to predict the next word based on the training. These large language models are general purpose. Like for example, how many of you work in say security domain? Right. So now if you have solutions like say bot detection or some kind of ML models, right? They're very fine-tuned for a specific purpose. They don't, like you take the model, you connect it somewhere, it doesn't work because that particular model is very specifically like fine-tuned for that use case. Talking about large language models, it's not. It's a very general purpose model where you can ask it to write code, maybe it writes code, you can ask to write a poem or a story, it will generate, it's very general purpose. Now, how does it predict the next word? The answer for that completely depends on the training. These large language models, to create the model, you have to train on huge amount of data. When you say data, it includes data from books, Reddit posts, blog posts, the internet, anywhere on the internet. That is why you always come across LLMs or like issues with LLMs saying that, okay, LLM is giving hate speech, or LLM is giving something that should not be, or it is giving something that is illegal in your country. Right. For LLM, it doesn't matter. It is trained on that data, and if the data is hate speech altogether, it will generate the next predicted word is hate speech, obviously. There are two parts of large language models. One is the parameters, and second is the inference engine. The parameters is what helps to decide what is the next, like what is the probability of the next word, and like go on produce the next words. And inference engine is I would rather, to simplify it, call it the runtime, because parameters by itself you can't do much. You need something to go ahead and actually execute it and get the next predicted output. So inference engine uses parameters and your text to go ahead and generate the next paragraph or next text. The theory is good enough. Let's go to demo. Let's take an example of rock, paper, scissors. Pick one. So this is the input I'm giving. This is the prompt I'm giving, and I want that to complete the prompt saying that, okay, pick a particular one from this. Now I'm using GPT 3.5 model. I'm not like let's take this for example. There are parameters like temperature and topic. We are not going to touch it for now, but later in the talk we'll touch it. The only thing that I'm changing is show full spectrum of the probabilities. Now when I click submit, okay. Nah, I don't think there's more of this demo is working anyway. Fine. Cool. So it used certain tokens, like I'll talk, like all this text, LLMs don't understand this as English terms. Rather it splits into tokens and then tries to do its math and predict the next word, and then it gives. And each word that it predicts has some kind of probability. For example, this is rock. Rock has 50% probability. So it always, it most probably picks rock. Let's run again. Let's run. It's not working. Okay. So you see that it is generating rock, and because it has the most probability, 50% compared to paper and scissors, which is somewhere down. Say I increase the temperature, which is a parameter, then things change a bit. So it again suggests rock. Okay, it for some reason is just generating rock. Now, if you use a large language model to create a random number generator, right, that's a stupid use case, because there is probability for everything that is generating. And if you use, say, GPT 3.5 to play rock, paper, scissors, and you think it is pretty random, and set the temperature and things like this, most of the times it generates rock. And similarly, you can see if you ask it to generate a number between 1 to 100, it picks up the 42 or something for some reason, because that is the most common number used by humans. So this is about the output prediction. If you use ChatGPT, right, you will never come across these terms called inference engine. You will not come across parameters and stuff, because that is because the entire thing is owned by them. All they give you is an API to access it. So you don't have to go through the hurdle of setting up your own inference engine on your infrastructure and like give your parameters file to that. Rather, on the vendor side, the entire thing is set up. They have the compute that is required for running the inference engine. They have the inference engine and the parameters. It is not publicly accessible. You can't ask OpenAI to give the parameters file. Rather, they give you API, whatever you are building, right? Maybe you are directly chatting with ChatGPT, the desktop application, or you have integrated ChatGPT with your applications. It speaks to those LLMs via APIs. So that is common across all the proprietary large language models, Claude, ChatGPT, and even some hosted models, like even Gemini for that reason. Now, on the other spectrum, we have open weight and open source LLMs. In the previous proprietary LLMs, right, we can't do much here. We have the parameters. All we can do is go ahead and like fine tune the prompts and do some kind of prompt engineering and ask it to refine its answer. But we can't change it, we can't tweak it, we can't like censor information from that large language model. But when it comes to open weight or open source LLMs, now these are something that you can go ahead and host on your premises and like use or do whatever you want with it. And there is a difference between open weight and open source LLMs. Like Llama, for example, from Meta AI is an open weight LLM where you can go ahead, use it for your research purpose, tweak it, do whatever you want. But if you want for commercial, you need a license. That is open weight. Open source, like for example, the DeepSeek model that was launched last week, I guess. So that is like completely open source. Like you do whatever you want. Like use it for commercial purpose, use it to ask very not so legal questions, it would still go ahead and give answer. And the entire thing would be on your premises where the LLM parameters, inference engine and the compute required, it will be in your infra, and whatever you are asking it, right? Like whatever kind of question you are asking, that will also be in your infrastructure. So you don't have to worry that maybe someone finds out. Now the interesting question that folks ask is, which LLM should I use? Like should I just use ChatGPT, should I use Gemini or Claude? What is, there is no single answer for that. Like, okay, just for my information, how many of you use Claude? Okay, how many of you use Gemini? Okay, so it's like ChatGPT, Gemini and Claude, right? Okay, interesting. Now it completely depends on your use case, which LLM to use. LLM, just because some random LLM said we got 90% in some benchmark doesn't mean it works for your use case. Go ahead, sign up to these LLMs or like host these LLMs and test your use case. Like if you want it to write a good answer or like good story, ask it to write and like you evaluate for yourself if it is correct or not. So there is no silver bullet saying that okay, this is the model that's going to solve all your problems and you just attach your bank balance to that and like keep asking questions. That's not going to happen. Like test it for your use case and go ahead. The second question after I say this is, okay, I have this model in mind, which one should I use? Should I use 70 billion parameters or 7 billion parameters, 90 billion parameters? These parameters depend on the training data. Like the tons of blog posts, books and all that was used for training generates this parameters file, and you can cut down that. Okay, I just want to minimize it to some portion of the internet and then you get a smaller parameter file. Well, or rather I could say, is a bigger parameter file or a large language model that uses a bigger parameter is always superior than a smaller one? The answer is no. Because the bigger the parameters, the more capable of it doing a large number of tasks. You can ask it to do a wide variety of tasks, but if you ask the same thing with the smaller parameter large language model, it might not go ahead and do that. But that should not stop you from going and executing your own use case. Like go ahead, test it with small parameters, then go to bigger parameters. It should, like whichever works for you, whichever is smaller and uses less compute, go ahead and use that. Yeah, pro tip number 2 is find an LLM that works best for your use case. Does anyone have any kind of question? Like don't think that someone would judge you. If you have any sort of question, please ask. Okay, is my talk going into your head or over your head? Sure? Okay, someone say what did I talk about in the last, like 2 slides back? What? No, someone say it out loud. Okay, okay. Cool. Alright folks, see I'm not your professor, right? Like the feel I get is like I have made you to sit here and like watch the entire talk. I get that feeling. So if you have any kind of questions, do ask. So let's skip this model cards. Yeah, sure. Thanks.
So you mentioned like 405 billion parameter. That was trained with 405 billion parameter. But if you're using small model, suppose it's a 7 billion parameter, in that you have made it chunks, like chunks of 5 LLMs of 5 billion parameters. Okay. And that is more relevant to bigger LLM model, which is 405. Right. So you mentioned ki bigger the model is more relevant than smaller. Why?
No. I did not say that. Rather, I said if you have a bigger model that has the capability to do a vast variety of tasks. Like if you ask, for example, if you ask a small language, large language model which uses smaller parameters, if you type Hindi in English, like kya kar rahe ho, these kind of things, it might not answer because it's not really English kind of thing. But if you ask a large language model, maybe it tries to answer. Or if you ask, or if you make it, what could be a good example? It's like, go ahead and try to define what quantum physics is to a 5-year-old. Maybe the bigger models might do a better job in it. But that doesn't mean it is always the case that bigger models is always perfect and the smaller parameters is not good. Rather, test it yourself. In my test, with respect to coding, I've seen like there is just 1 or 2% difference when I use smaller with the bigger models.
In case of agent, that would do better, right? In the chunks only.
Right.
If they are created as agents, like 5 of the small LLMs model are created as an agent, because they are learning as well, right? From every iteration, between those 5, they are learning as well, right? They can do better than 40 billion parameters.
No, agent is something that uses large language model, right? And if your task is fine with that large language model, then your agent will go ahead and do that. And what you are saying is whatever external parameters that we are providing, like what is the environment, what is the code used, or where is the network, where it is present in the network, these kind of things, then it has it in the memory and might use it. But let's say if your model does not know what a CIDR, like cider range is, then it would fail, like irrespective of your agent knowing where it is in the network. So this is with large language model.
If I can say on this part, like large language, bigger parameter doesn't mean it is a specific use case of a business. For example, a business is running in test process. While the bigger parameter, so many rules and everything used for trading from the spots, from politics or other domains, it might not give a better result. But if it is related to the training model, which is having database related to healthcare, it will give a better result even on smaller domains.
Okay. I thought I'll explain about the model cards, but let's not go there. Okay, now when you're doing anything with the large language models, you first detect or first find which large language model you're going to use and what is the parameters that is needed. So that is always the first step. After that, how do you get better output from that is using 2 other things. One is update the configurations, and second is update the system and user prompts. If you remember from the demo, we had something called temperature and toppy. Like these are the configurations I'll be talking about. And system and user prompt, I'll give an example. Now the first configuration is temperature. Like it's just a number, or maybe a decimal number between 0 and 2. Towards 0, if you set the temperature to 0, it is more deterministic. Like if you ask a question, it will answer that for like with respect to that question. But I would say deterministic does not mean same. Like if you give a paragraph and run it 10 times, it might answer it, but not all answers are the same. Like it could do subtle tweaks and like completely like derail from the story that you said, these kind of things. But if you set that to 2, now large language models are like, they just print some random outputs. Like it could be something related, it could be completely weird outputs. It depends on each large language model. And the second parameter that you can tweak is top P, which is again, it's not from 0 to 2 like temperature, but rather 0 to 1. When you set the top P towards the 0 side of the spectrum, then it chooses lesser choice of words than 1.0. Like for example, let's say if you're asking sports and ask it to predict the next word with top P equals to 1. Are you folks able to see this? Okay. So with respect to sports, the next predicted word is activities, and it is predicted based on all this. Like it has so many options and it predicted or it used activities as the next word. But if you lower the top P, right, the number of words that it can use reduces. So in this case, if you just use sports with top P is like lesser than 1, then the words decreases. Like it has to choose from n and a comma. So it probably chooses n. Let's take a look at the demo. I hope this works. By the way, folks, this playground is deprecated by OpenAI and will be removed in some time. So let's security code. So like I'm just trying it. I don't know. Let's set this temperature to 0 and the max length to maybe 140 or something. I'm not touching the topic. Let's submit it. Okay. So large language model thinks security board is a 3D action game where you can play a security guard on the board. Interesting. Like by the way, this demo I have not done it. Like this is the first time I'm seeing this answer. Now let's say we take this temperature to something like 7.0 and remove all the things, and again it says it's a 3D action game where you play as a security guard on a boat. Okay. Now increase it to 2.0, run it, it is same. And do you folks like guess what is happening here? Like I have changed the temperature from 0 to 2, but it is giving almost similar answer. Like what do you think is the reason? No, temperature is relevant, but there is something else. Huh? Yeah, the top P value that is set to 0, which means it's going to select from a very small like list of what integers, numbers, or like characters, whatever it is. So now let me set it to 1, and the temperature is also set to 2 point. And you ask, this is the output. Like it is, I do not know if this makes any sense. And let's try to. Okay, now security boat is a vehicle. Description, it's a boat. And a security boat is type of vehicle used for patrolling bodies of water. And whoever came up with the security boat, you have to be proud of this. Right. So yeah, the end thing is if you change or if you tweak these parameters, especially the temperature and the top P, you're going to get different outputs. And based on your use case, go ahead, play around with these two parameters, and whichever gives good results for you, take it. Like in most cases, what folks do is they set the temperature to 0 because this creates some kind of very deterministic value, and they might or might not change top P value, but it's up to you. Now let's get back. Let's talk about prompt fine-tuning. Whatever you passed, right? Rock, paper, scissors, pick one. Or even the previous one, what is security board? Security board is a blank thing. All these are prompts. Like you are giving something to large language model and ask it to predict the next words or like complete that. Now, there are two prompts when it comes to large language models. One is the system prompt that you can think of it as a guardrail or something that sets the context to the entire large language model. You can say that in a system prompt that, okay, you are a 5-year-old kid. You can set that as the system prompt, and whatever is sent in the user prompt, LLM will always answer as a 5-year-old kid because the system prompt is not modifiable. It's like once you set it from your server, you can always you can restrict customers setting that on your backend. You can always send their input as a user prompt, and then it can go ahead and say that, okay, if whatever is your system prompt, it's going to take that tone, take that instructions, and go ahead and use that. Would both these prompts be required, a system prompt and a user prompt? It's no. It either needs it needs one prompt at least, or you can pass both the prompts, like system prompt and user prompt. That is still fine. Okay, let's look at another demo. I'm using Google Colab for this demo. Okay, meanwhile it is connecting to the VM, let me explain the code. So I'm fetching the OpenAI API key from the environment variable, using it, and I have two prompts here, system prompt and the user prompt. And then ask it to generate a response. I set both the I set temperature and max tokens, and I use GPT code to code. It is connected. Are you folks able to see this, the demo at the back? Okay. Okay, I've used both the system prompt and the user prompt. System prompt says the users purchased CloudSec sunscreen product on 1st Jan of 2025. This is just a random example. And now user prompt is set to what is the cost of iPhone. Like these are two different things. Like this is something the user, maybe your customer is asking, and this is the system prompt that you are setting, right? Now in this code, I'm saying that, okay, just use the user prompt. I'm not setting the system prompt at all. So it just gives that iPhone 14 Pro Max is the latest model and it costs somewhere around $1,000. Now let me go ahead and set the system prompt as well. I'm passing both the system prompt and the user prompt. So it again goes ahead and says that the cost of iPhone can vary widely. Now let me change this. Change the system prompt and say, don't answer any question apart from the sunscreen. Okay. Any other question not related to sunscreen? So now let me go ahead and execute it. You can see both my system prompts and user prompt is correct. Let's change it. So it says that I'm here to help with questions about sunscreen. And if you have any inquiries about sunscreen products, feel free to ask. So a system prompt, whatever you said there, is going to define what the user prompt is going to be. Now if I ask, okay, when did I purchase my sunscreen? Thank you. Okay, it says 1st of Jan 2025. But let me remove this. Let me remove the system prompt and just ask it. When did I purchase my sunscreen? It just doesn't have it. So system prompt, one is it sets the guardrails on what the user prompt can do, and second is it also gives information on what can be read to you. Like if you look at so-called RAG models, this is what happens. I'll show a demo of RAG model at the later part of this talk, but it fetches the contextual messages that are pretty contextual for your query and sends it in the system prompt and asks it, okay, just kind of summarize this information or fetch the information. AIs or this LLM models are going to summarize that for you. Cool. Any questions so far? Whatever. First is go ahead and fetch the best large language model that's going to work for your use case. And second is you are going to tweak the temperature and the topic. And the third one is you change the user prompt and system prompt. You kind of fine tune it or tweak it to get better results. There is this term called open, one shot or few shot prompts. It's just a fancy way in ML saying that you give examples. One shot is one example, few shot is few examples, zero shot is zero examples. Simple as that. If you ask an LLM to go ahead and do certain things, it might just randomly look at its data and go ahead and predict something. But if you give example that, okay, this is how you solve a problem, and then ask it to solve a similar problem, then it performs better. In this example, if you can see, this is zero shot where you're just asking something, some math question, and ask it for the answer, and it gives a wrong answer. But instead, in a few short chain of thought, which we'll talk next, in a few short example, you give the example, you give the question, and you also give the answer. Then you ask the next question. And then it goes ahead, tries to use the entire input that you gave and predicts the better answer. So one, for prompt fine tuning, one is one shot or few short prompts, and the second one is chain of thought. Chain of thought is still not understood well by folks. Why does it work? Why does it not work? No clue as far as I've read. Asking the large language models to take some time to think somehow gives better answers, or think in step by step also gives better answers. So in this case, it's a few short chain of thought. You're giving few examples, but if you don't have any example, you can just go ahead and ask in the user prompt or system prompt saying that think deeply before giving answer, or think step by step and provide the answer. It just performs better. Now, a common pattern across these large language models, if you observe, is you have a human element who is interacting with large language model. You as a human go ahead, interact with the large language model, ask it to perform certain things, or ask it to generate something, and it gives you the answer, and you're going to take that answer, put it somewhere, use it. Now, how can you remove this human element? How can you automate it? That is where things like RAG and AI agents come. But before we go there are certain problems with large language models. These large language models, they have a cutoff date. Meaning the training data that they used has an end date. If you look at GPT-4o mini, the knowledge cutoff date for this model is October 2020. If you ask it any question of any news article or anything that happened during that period or even before that period, it can go ahead and give an answer. But what about you ask an answer for your, you ask when your college exams are, or you ask what was the latest AWS news, or what was the latest AWS hacks that happened. It's not going to know because it doesn't have the data. So it is trained on data which is old right now, and second is text generation isn't sufficient. You need some way to automate it. So that is where RAGs come in. Retrieval augmented generation. It's you pass example or you pass the text. In the previous example, I said you purchased the sunscreen on 1st Jan, and you ask in the user prompt when did I purchase? It knows when you purchased. So things like these. Again, let me skip multimodal RAG, not complicated. And finally, the AI agents that you were talking about. These, again, there is a debate on what an AI agent is. Is it something completely autonomous, or it is something that follows a particular workflow that you define? Folks debate on this. But a full-fledged AI agent thinks for itself and takes action on itself. Like if you ask it to write code, then it has to write code. It has to debug any issues that it has. Go ahead, maybe deploy it. So that can be an AI agent. But if you just ask it to write code and it gives you prompt, like it gives you the response, and you take that and do something, it's not an AI agent. Another thing is you don't need LLM for every problem that you have. You don't need AI agents for every LLM problem that you have. Like if it works for your use case, go ahead, use it. Else, stay away from that because it can get complex at certain points. Now comes the most, I think, most relevant part when it comes to security communities. Large language models in security. I have personally seen or I have personally experimented with certain examples, so I can watch for these kind of examples. One is retrieve data from personal nodes, whether I'm freelancing, whether I'm doing red teams or something. Now I can store all this in my notebook or maybe Obsidian connected with large language model and ask it like, okay, what was the low-hanging fruits or what was the low-hanging bugs for this particular client? And it gives those bugs and maybe I can think of, okay, can I chain it with something else? So this works pretty good. Offensive tasks include, which involves natural language, especially if you're talking about phishing and wishing. These are super amazing because end of the day they're generating text, right? If you ask it to write, okay, you're a Nigerian king and you want to donate your money to some person, write an email for that, it's going to write beautiful emails for that. Like that is the capability of large language models. So you can use large language models for offensive tasks where natural language is used. And the other two examples, which are not 100% there, but it is still improving, is code, policy, query, CI/CD, pipeline generation. So if you have a large boilerplate that you want to automate, you can just ask large language model to give it. It gives you the entire code. And one interesting thing I've looked at is, I'm not a coder. I'm not a perfect programmer. I'm not a lead code person, these kind of things. Rather, I have a lot of ideas that I need to go ahead and implement. I was able to go from idea to code to prod, meaning my own personal VMs, and do a lot of security research in 3 or 4 days. And all I had is an idea. I didn't even know how to code it perfectly. So LLMs help there. And if you are into product security or AppSec, threat modeling and design reviews are there, but not 100%. Maybe it helps you with your workflows. Let me give a demo of my cloud security research that I'm talking about. If you ask large language models, right, there are two things. One is it might not know what is the data that you're talking about, like it might not know the latest features. And the second thing is it might not hallucinate. Let's say it censors a lot of things. Like if you ask how to create a blank where blank is like something illegal or something not very good, it censors it. Now, if you want large language model to go ahead and use it or give the data and ask it to create something, you can use RAGs. How do I use in security research? Is I take a lot of documentation, like just pipe it to large language model and ask it questions like what are the limitations of this. Large language models by default they can't provide it, but if you provide the relevant data to it, it might summarize it. Okay, it's still connecting. Let's wait for a minute. Okay. Again, I'm using Google Colab, which gives you free VM to go ahead and use it. I'm using a VM with GPU to make things faster. Similarity search model. Similarity search models, again, part of large language, but they are not into generation of code, rather searching the relevant topics. So I found, during my test, I found this model is way better than other models and bit cheaper cheaper when it comes to compute and resource utilization. So I go ahead, initialize this class, and create, like I'm downloading the model now. So it goes ahead, it downloads the entire model, which is 1.7 GB. Okay, now the model is downloaded successfully. I'm using a document called AWS WAF Docs, which is just the documentation of AWS WAF. And it would go ahead, load this PDF and like start chunking it, and everything is in the memory. It starts, it might take a couple of minutes, and it, okay, meanwhile, okay, let this keep loading. It will take 2 or 3 minutes. I'll go back to the presentation and show what's the output later. My thoughts on, after experimenting with large language models for my day-to-day workflows, I found that large language models with respect to security is good if you have non-recurring unstructured random inputs in human language and which can't be automated. So that is what I would say. If you have certain tasks which can't be automated, right? You can't write Python code to go ahead and do that task, maybe set up a cron job every 24 hours and do it. That is not possible. Maybe you have to look at large language models of a brand new technology that you do not know, and learning that itself takes some time. Maybe you can use large language models for a one-time thing to go ahead, do a demo of it, like just get the policy or code for that. And if there are lots of random inputs, like okay, one day you're asking for code, one day you're asking for health related queries, one day you're asking for something else, then large language models might be helpful. But if you have the other, if you have a recurring, structured and like common input given to your program, then use a program. Don't use large language models. That is, using a program is way more deterministic and it gives better output compared to large language models. And the other part is ensure that the produced output is not detrimental. Don't connect your large language models and give it permission to delete your database. Like, it might work for your use case, but again, if someone like just plays around with the large language model and says delete the database, it will be a nightmare for you. A few good examples is idea to code, as I mentioned earlier, contextual actions, threat modeling or design reviews. Bad examples is performing or replacing well-performing ML models with LLM. Don't do that. Replacing dashboards or using AI as security tools. If you want to scan your network, use Nmap, not other things. If you want to scan your cloud, use something like crawler, not large language models. So yeah, folks, that is it. Let's see the demo. I think I overshot. Okay. Here the embeddings are generated. I could go ask questions like how do I bypass AWS WAF, or what are the limitations of AWS WAF, and set the top K5 as just give the topmost 5 documents that you get. Now from the documentation, which is a 1000-page documentation, if I ask or like search for limitations, it doesn't give what's the output. But if I search using large language model, you can see that AWS WAF has following quotas, and then it doesn't support inspecting very large contents for web component body, and it also has web requests with 205. So it has a limit. It doesn't send more than 200 headers. So if I'm an offensive cloud security researcher, this is my starting point. Go ahead, create payloads to bypass AWS WAF by either sending a lot of post body data or like a lot of headers. So yeah, folks, that is it. Thank you all for listening. And yeah, if there is any questions, I would.